Now let's take a more close look at the lateral surface of the human brain. And what we're looking at here is the right hemisphere of a brain specimen. And to begin with, let's find the central sulcus. The central sulcus is a long, roughly straight sulcus, except for a distinctive S-shaped bend that represents the hand in the somatic motor and somatic sensory cortex. But otherwise, the sulcus extends from the dorsal midline to the lateral fissure in roughly a straight trajectory. All of the cerebral hemisphere to the front of that central sulcus is the frontal lobe. And the frontal lobe is comprised of a precentral gyrus and then 3 gyral structures that run more or less in the long axis of the hemisphere. Near the dorsal midline is the superior frontal gyrus. Near the middle of this frontal lobe is the middle frontal gyrus. And then along the inferior margin of the frontal lobe is the inferior frontal gyrus. So again, superior, middle, and inferior frontal gyri that are separated by 2 meandering sulci, an inferior frontal sulcus and a superior frontal sulcus. Now let's look behind the central sulcus at the parietal lobe. So again, here's the central sulcus, and the posterior boundary of the central sulcus is the long, mostly straight post-central gyrus. And then just behind that post-central gyrus, there are 2 gyral formations. Now there are subdivisions that we could name, but for our purposes, we'll keep it simple and talk about these 2 structures as an inferior parietal lobule in this region of the parietal lobe, and then a superior parietal lobule, which is up here along the dorsal midline of the hemisphere. And between the superior and inferior parietal lobule is a deep sulcus of the parietal lobe called the intraparietal sulcus. And that sulcus runs in the long axis of the hemisphere, approaching the central sulcus at nearly a right angle. Now, just behind the parietal lobe is the occipital lobe. And it's somewhat arbitrary how we define the boundary between the occipital lobe and the parietal lobe. It almost doesn't make sense to do so based on the function of this part of the cerebral cortex. But based on the anatomy, as we view the lateral surface, it is helpful to define that boundary. There's a deep sulcus that's more obvious along the midline that comes out to the lateral surface of the brain in this location. That's the parieto-occipital sulcus. So if we can draw an imaginary line from that parieto-occipital sulcus down to a notch formed by the way the dura tends to restrict the development of the inferior surface of the occipital lobe, we have a boundary that roughly divides the occipital lobe from the parietal lobe. This notch that we can see right about in this region, that's called the preoccipital notch because it helps to define the anterior boundary of the occipital lobe. And now let's go inferior to the lateral fissure, which is located right here, and explore the features of the temporal lobe. From the lateral surface of the hemisphere, we see 3 long, straight, parallel gyri, known as the superior, the middle, and the inferior temporal gyri. I want you to notice that this arrangement of 3 long, straight, parallel gyri is quite similar to what we found in the frontal lobe. So between these 3 gyri are 2 sulci that are more or less straight and parallel. There's the superior temporal sulcus between the superior and the middle temporal gyri, and then the inferior temporal sulcus between the middle and the inferior temporal gyri. To get a better look at the inferior temporal gyrus, we'll need to angle the temporal lobe just a bit so you can see the lateral surface curving into the ventral aspect of the brain. We'll see the rest of the gyri and sulci of the temporal lobe when we explore the ventral view of the brain in another video lesson. Now, if we were to compare one hemisphere to the other, we're looking now at the right hemisphere, and if we looked at the left hemisphere, we would see all of those same gyral features, although there may be a few aspects of this lateral view that could be a bit different. One of them concerns this deep fissure called the lateral fissure. This lateral fissure tends to be longer and straighter in the left hemisphere compared to the right. And this, we think, accommodates some of the specialized regions of the posterior temporal lobe and inferior parietal lobule that have to do with processing human language. So in most of us, our lateral fissure is longer and straighter in the left hemisphere as compared to the right hemisphere, where that fissure often takes a sharp upward bend rather than extending further back in more of a straight line. So that's a brief tour of the lateral surface of the human brain.